This is a model of three-phase double circuit, power line 22 km long. The model includes transforming substation and supports with 6 suspension strands. The substation has 2 electric transformers, main and backup, powered by either 1 or 2 separate lines. In this case, 2 electric transformers, main and backup, powered by 1 line. By applying voltage to the line, we will demonstrate its operation in normal 3-phase double circuit mode. As it can be seen, the electrical transformers are on. Voltage is applied to A, B and C phases of the first 3-phase line. On the first multimeter, we can observe the presence of 3 circuit voltage. Voltage is applied to D, E and F phases. On the second multimeter, we can observe the presence of 3 circuit voltage. Load 1 and load 2 are connected, specifically blow heaters. We are observing the operation of both loads. While in operation under the load, we are disconnecting 3 phases in the line. As a result of this action, load 2 has been turned off. And now, let us connect to the first and second 3-phase lines our device, know-how, which will change the line's properties. The device is being connected to the output substation. The device is being connected to the input substation. And now, let's disconnect 3 phases in the line in the same way. Now, we are observing new fundamental property of the line. The load is still in operation. We can disconnect next 3 phases in the line. The load is still in the operation. We can disconnect up to 3 phases in the line in any order. The load is still in operation. These new properties of the ELT let to perform maintenance works and servicing without disconnecting the consumers. Let's demonstrate other fundamental properties of the ELT. Melting ice without disconnecting consumers. The artificial ice is being created on the suspension strand of the ELT with liquid nitrogen. The mode of ice melting is turned on. As it can be seen, the load, specifically the computer, is not powered down with ice melting. We are observing the temperature of the 6 suspension strands and the humidity while in the automatic mode operation of the ice melting. The ice of -50°C melted within 2 minutes. Another know-how. For the purpose of explanation, let's consider the operation of a conventional induction motor and a new-type motor in open-phase mode. The 3 phases are being applied to conventional induction motor and to new-type motor. The operation of both motors in 3-phase mode is shown. The conventional induction motor with a power of 10 kW is working. The new-type induction motor with a power of 7.5 kW is also working. We are observing the motor rotational rate in laser tachometer. The phase in the supply circuit of each motor is disconnected. Let's turn off the new type induction motor without a phase. The motor is working. Let's turn on the conventional induction motor. In operation in such mode induction, motor will fail or not be forced to turn off. The next know-how. Let us introduce you a unique phase stabilizer of a type PSV, which allows induction motors to be continuously operated and start and stop smoothly in open-phase modes and to be operated in power-saving mode. Let's start conventional induction motor with a power of 18.5 kW in the power-saving mode. The power consumption of the motor will be judged by currents and voltage shown in the multimeter. The currents and voltages are observed in the stable operation mode of the motor. The device analyzes induction motor and during 30 to 35 seconds lowers its power without changing the number of rotations at the shaft. the lowering of working current of the induction motor with a power of 18.5 kW is observed. The total economy of the consumed energy is idling reached 50%. Let's demonstrate the operation of conventional induction motor at the phase break. The motor is still in operation. The phase is absent. The motor operates stably at phase break in power-saving mode. The device is turned off. Let's demonstrate a smooth start of the motor without the phase. As it can be seen, the motor is smoothly started. The device sends the information about the status of the motor by GSM channel. And if the operator didn't make decision during the started time period, will smoothly turn off the motor for averting the hydraulic impact. Meanwhile, this display duplicates the warning: the phase is absent. The next know-how has been tested on the operation of the server on small data center. Accidental situations will be modeled in three-phase network, specifically the breaking of neutral or any of the phase. Except the servers, the plasma display of the diagonal of 150 cm is connected to three-phase network. We know that in the case of breaking of neutral in three-phase network, the phase voltage is increased from 220 to 380 and sensitive equipment breaks down. The quality of electrical energy will be measured by showing a new CA8335 analyzer. Let's demonstrate that with the presence of our equipment server will not break down. We will see whether the disconnection of phases will lead to powering down the servers or not. The presence of three feeding powers is observed. The neutral is disconnected in three-phase network. We see that the voltage in three-phase network didn't change. The neutral is being restored in three-phase network. The A phase is disconnected with two one-phase automatic opening circuit breaker. At measuring analyzer can be observed that A phase is absent, but computers are working. The A phase is restored. The B phase is disconnected with two one-phase automatic opening circuit breaker. B phase is absent, but servers are working. The B phase is restored. The C phase is disconnected. The absence of phase and the stable operation of the servers is observed. One of the fundamental properties of new ELT is the protection of the equipment from high-voltage impulses caused by lightning strikes while in operational load, specifically the Dell's server. As it can be seen, the other equipment, specifically plasma monitor, is turned off at high voltage discharges, up to 400,000 volts, produced by Tesla generator, but connected to our ELT computers at high voltage impulses in the network are functioning and process images.